So I think we'll proceed to start as our participants start logging in. And so greetings everyone, and welcome again to our InfoFish webinar, webinar series 2020 on technical advancement in fisheries and aquaculture. It gives me great pleasure to welcome everybody and our esteemed panelists to this functional aquafeed sustainable solution for the industry webinar. This is the fourth event of InfoFish webinar series that we've been organizing since early this year. And today, this event will address the issues and challenges of the global aquafeed industry as we wade through this COVID-19 pandemic sort of stalking us since early this year. We will also be addressing, among other issues, alternative sources of raw feed ingredients and the role of functional feed additives in the aquafeed industry. We are happy to announce that Cobian Algae Ingredients is the exclusive sponsor of this webinar. Just to quickly or briefly say that during this period of pandemic, we've been seeing fluctuations in the raw material feed prices, and the growing environmental and human health concerns are projected to impede the growth of the industry, aquafeed industry. So the application of functional feed additives not only satisfies the basic nutritional requirements to target species, but also supports the health and stress resistance of aquatic animals. Asia has a rather, Asia Pacific region has rather a high share in this aquafeed industry. And according to analysts from Rabobank, the aquafeed market is projected to grow 7.2% until 2030, until the year 2030. So I'm honored to introduce to you, welcome and introduce to you our esteemed panelists today. We have with us Dr. Albert Tacon, founder and owner of Aquahana LLC Aquaculture Nutrition and Feeds Consulting Service, Hawaii, USA. Dr. Fusi Go, who's Director and Business Development Asia, Cobian Algae Ingredients, the Netherlands. Ms. Runa Kauri, Director, Sustainability and Public Affairs, Eka Biomarine AS, Norway. And Dr. Kabir Chowdhury, who's the Sales Director, South Asia, Jeffo Nutrition, Inc., Canada. As you can see, we have a team of panelists today who will be discussing very important topics of this very important focus area. It also gives me great pleasure to welcome and introduce to you the moderator for today's webinar, Mr. Sandeep Arihau, Vice President, Sales and Marketing of Growell Feeds Private Limited in India. Mr. Sandeep Ahirao has more than 33 years of professional experience in the areas of fisheries and aquaculture, including aquafeed, feed additives, aquatic animal health products in South and Southeast Asian region. Mr. Ahirao has performed diverse techno-marketing and key managerial role in some of the leading global multinational companies like Lallemand, Animal Nutrition France, PT Nautilus, Indo Multipercasa, Indonesia, Inve, Belgium, Novozymes, USA, Biostat, India, Symbiosis, India, the water-based, and the Hindustan Lever. So he is also the founder, secretary, and currently EC member of the Society of Aquaculture Professionals, India. He's currently holding the position of Vice President, Sales and Marketing Aquafeeds for domestic and international market of Growell Feeds India. So just to give you a quick overview of the program today, we will begin with a brief presentation by our exclusive sponsor, a presentation which will be done by Dr. Fusi Go. And thereafter, Dr. Sandeep will take over as the moderator, and we will have the first presentation by Dr. Albert Tacon, and followed by Dr. Fusi Go, Ms. Runa Kauri, and then Dr. Kabir Chowdhury. So after each presentation, we will have a Q&A session, and we invite panelists, we invite participants to address your Q&A through the Q&A tab. We would prefer if all the questions are in the Q&A tab itself so that it's easier to monitor. So we advise everybody to put in your questions on the Q&A tab. And thereafter, we will also have a final closing after that. So just a quick on the guidelines. I think I've already mentioned on the Q&A section. We will now proceed with the presentation by our exclusive sponsor, Cobian Algae Ingredients. Dr. Fusigo, over to you.
Thank you, Charlene. I'll go ahead to share my screen.
Yes.
All right. So good morning, good afternoon, and good evening to 200 over participants from all over the world. Thank you to InfoFish for giving us the exclusive sponsorship opportunity. And I roughly will spend about 5 minutes to go through, to introduce to you about Cobian. Cobian is, our purpose is we champion preservation in all its forms, preserving food and food production, health, and the planet. By using science to propel nature's ingenuity, just to get my pointer up. We have 3 divisions. Okay, before that, so we follow United Nations Sustainable Development Guideline called UN SDG. The UN SDG was agreed by all the 193 UN member states in 2015. These will guide the government and civil society and the private sector in a collaborated effort to for changes towards sustainable development. So out of the 17 SDGs, Cobian contribute to at least 3. Number 2, the zero hunger. Number 3, good health and well-being. And number 12, responsible consumption and production. Cobian as a global presence, our headquarters is in Netherlands, as Charlene mentioned. We have offices and distributor center in Asia, in North America, and as well as in Latin America. We have 3 divisions. The first one is called Food Solution or Sustainable Food Solution. And second one is lactic acid and specialty. The last one is incubator, including the algae ingredient. It's the division I'm in. Cobian is a mid-sized company. Our revenue turnover last year is about 1 billion euro, and we have about 2,000 employees. So very briefly, so the first division, the food solutions. The turnover of the business is about 529 million euro.
Dr. Fusi, sorry, may I just interrupt? Yeah. Would you mind putting your presentation on the presentation mode so it's bigger? I think.
Yeah, full screen.
Yeah, full screen.
Full screen. Okay, yeah. So how do I do that?
Do you see that?
Seeing your screen, right? Just to, I think. You have, if you have 2 screens, just move to 1 screen, maybe it will help.
Okay.
Do you see that you have those 4, 5 pointers at just below the slide on your left? Yeah.
Right.
Okay, so you got to choose slideshow mode.
Slideshow mode.
Yeah.
Okay.
Yeah,
This
the
one?
big.
Yes, perfect.
Yeah.
Ah, okay.
Great, great. Thank you.
Apologize.
No problem. Thank
Okay,
you.
now back to Marwa. Yep. So for the sustainable food solution, the biggest division we have, we follow two themes: preservation, using natural through fermentation, all our natural products, and second is our functional systems. The next division is the lactic acid and specialty, of which Corbion is a world leader in lactic acid productions, and we have about more than 40% of market share in lactic acid, and we are leading the market growth. And we also have a joint venture that we'll talk later on, together with Total, a French company, to produce PLA, the polylactic acid, for bioplastic. So the turnover of this lactic acid and special division is about 260 million euro. And this is a picture of the factory in Asia, in Thailand, in Rayong actually. It's a 50-50 joint venture with Total. We are producing PLA. PLA has a lot of applications, including packaging, automobile, and consumer goods, electronics. So it's actually very related to our day-to-day life. So these were made from renewable raw material, and they are compostable, and they will make us less dependent on fossil fuel. Okay, the last division, the incubator, where the algae ingredients have fit in. The platform center on innovation of food and animal nutrition specialty ingredient derived from microalgae. So omega-3, algae omega-3 for animal nutrition, which I'll cover later on in my talk, and tailor oil, structural fat, and protein for food, personal care, and industrial applications. So we have R&D center and a pilot plant in San Francisco. And we also have a big industrial scale facility in Orinjuva, Sao Paulo state of Brazil. Yeah. So besides algae omega-3, we also make algae protein. And we enter into a joint venture development with Nestle to develop algae protein for human food. And so it's getting a big, very hot for plant-based protein for the consumer market. So that's all about Corbion in a very short period of time. So thank you very much for your attention, and thank you once again to Corbion, to InfoFish. Okay. Okay. So back to you, Shirlene.
Thank you, Dr. Fusigo. That was a very enlightening presentation, and interesting to see what Corbion has been working around. So without further ado, just before I hand over the session to Dr. Sandeep, we will have now the poll questions launched, and we kindly request participants to give us your feedback on some of the issues that is being raised under the poll. So thank you very much again, Dr. Fusi, and Dr. Sandeep, over to you. Thank you.
Thank you, Shirlene Maria. And first of all, I thank InfoFish and particularly Shirlene Maria and Sujit for inviting me as a moderator for this very important webinar. And so good morning, good afternoon, good evening to everybody, depending on which time zone you are. And so welcome to InfoFish webinar series 2020. So this is the fourth episode of its kind. This is a very good initiative on the part of InfoFish. Now this one is entitled Functional Aquafeed, the Sustainable Solution for the Industry. So who have just logged in from different time zones from the globe, we all welcome you. This webinar is exclusively sponsored by Corbion Algae Ingredients from the Netherlands. And my name is Sandeep Ahir Rao. I'm working as a Vice President Sales and Marketing for Growell Feeds Private Limited, India. And I happen to be the Founder General Secretary of Society of Aquaculture Professionals, India, and currently holding the post of Executive Committee member. So I'll be moderating the webinar today. So now let me tell you about the objectives of this webinar. The invited panelists will discuss about the issues, challenges, and the way forward during post-pandemic period, sustainable and alternative sources of feed ingredients, and role of functional feed additives in the aquafeed industry, which is becoming more important day by day because of the number of challenges being faced by the aquaculture sector all over the world. So it's my great pleasure and honor to introduce Dr. Albert Tacon, who himself is an institution and actually doesn't need any introduction. But still, since it's my pleasant duty to introduce him. Dr. Albert Tacon accomplished his BSc degree in Botany and Zoology from the University of London and PhD degree from the University of Wales and postdoctoral fellowship from University of Stirling, Scotland, UK. So during his 40 years of professional experiences, Dr. Albert conducted many aquaculture researches and development works with a special focus on aquatic feeds and nutrition, and increasing the contribution of aquaculture to global food security and poverty alleviation. He had 14 years of in-house experience with FAO and had the opportunity to work with many national, regional, and international aquaculture development projects and within the regular program of FAO in Rome, Italy. So in fact, I had the pleasure of meeting him way back in 2009 in Jakarta. So I'm sure he doesn't remember. So he has 44 in-country work experiences with the international and national agencies in aquaculture and aquaculture nutrition related activities from Asia, Oceania, Africa, America, Europe. He has more than 228 aquaculture related publications and 1 patent on aquaculture technology. He has been affiliated with many professional bodies like International Foundation for Science, Sweden, Aquaculture Working Group, and member of American Association of Advancement of Science, World Aquaculture Society, and as well as Asian Fisheries Society. He has also been contributing in many distinguished journals, example reviews in aquaculture, aquaculture nutrition, aquaculture research, and International Aquafeed magazine. As an international consultant, he has been providing consultancy services to more than 31 global feed and nutrition companies across the globe. Wow. He started his career as a lecturer in nutrition in the University of Aston, Birmingham, UK, and was also the visiting professor for the Universidad de Las Palmas de Gran Canaria, Spain. He was the US System Aquaculture Coordinator at the University of Hawaii and Technical Director of the Oceanic Institute, Hawaii. At present, he is the founder and owner of Aqua Hana LLC, Aquaculture Nutrition and Feeds Consulting Services, Hawaii, USA. Today, Dr. Tacon is going to discuss on the issues and challenges for sustainable aquafeeds. Thank you, Dr. Albert. It was a comprehensive present. Oh, okay, sorry. So now I would additionally request Dr. Tacon to also touch upon the pandemic situation with respect to the region where he is residing in the American region, as well as globally, and what impact you think it will have on aquaculture. Over to you, Dr. Tacon. Thank you.
Okay, thank you. Thank you very much, Sandeep. Thank you so much to, can everybody see this already? Yeah.
Yeah.
I would like to thank InfoFish for inviting me, and especially Corbion for setting up this, for sponsoring this session. I just want to acknowledge the Aquaculture Nutrition Network that Kabir is managing, and aquafeed.com that is always supporting me. The topic of my presentation today is issues and challenges for sustainable aquafeeds. What I'm going to present today is a summary of a larger paper that I'm writing together with Mark Metain. And so this is just really a summary of the paper that we're writing. It's really important that at the beginning of my presentation, I give a definition of what of how I view sustainable development. Sustainable development is the handling and conservation of natural resources and the orientation of technological and institutional changes in such a manner so as to ensure the continuous satisfaction of human needs for present and future generations. Such sustainable development conserves land, water, plant and animal genetic resources, is environmentally non-degrading, technically appropriate, economically viable, and socially acceptable. And the important point is that sustainability rests on three pillars that you can see in the bottom here. The pillars of social, environmental, and economic sustainability. And so really this, the presentation is really my view and Mark's view on suggested criteria for sustainable aquafeeds. Obviously other people will have different interpretations. This is my view, okay? And so when I look at sustainable aquafeeds, we wanted to look at 4 different levels regarding feed formulation and ingredient selection, feed manufacture and feed quality, on-farm feed performance and impacts, and finally fish quality and food safety. And I'm just going to go briefly through each one of these points and just summarize the main areas. And so when it comes to, I'm trying to remove my pictures. Okay, good. When it comes to feed formulation and ingredient selection, we've split the suggested criteria for sustainable aquafeeds into required and recommended. So in terms of required, I'm just going to list off the various criteria. The need to prohibit the use of non-sustainably managed marine feed resources. Number 2, the need to prohibit the use of non-sustainably managed terrestrial feed resources. It's not just aquatic resources, but also in the terrestrial sphere as well. We need to prohibit the use of non-approved feed ingredient sources. For some countries, for religious grounds, we cannot use certain ingredients. For other countries, we cannot use genetic ingredients. So whatever is the approved and non-approved ingredients, we have to abide by that legislation. We need to prohibit the refeeding of ingredients derived from the same species for biosecurity concerns. We need to prohibit the use of spoiled and or adulterated feed ingredient sources. And finally, we also need to prohibit the use of non-approved chemicals and feed additives. So this is required. In terms of recommended, the need to reduce country dependence upon imported feed ingredient sources and encourage the use of locally produced, sustainably managed agriculture and fishery byproducts. Again, one of the unique things of Asian aquaculture is, yes, we have a very big sector, but most of the countries depend on imports to support their feed industries. We need to try and limit in future the selection and use of potentially food-grade ingredient sources. It's much better if we can use feed-grade ingredients instead of using potentially food-grade ingredients that are going to compete with human needs. And finally, we need to make sure that we formulate feeds to the known requirements of the target species that we are producing. What did I do wrong here? I'm trying to go for my next slide. Sorry, I'm going to try and, okay. In terms of the different protein sources, we have plant proteins, we have terrestrial protein sources from the rendering industry. These are plenty enough for the sector at the moment. In the future, Single cell proteins, the algae, the yeast, the bacteria, where you can grow them on substrates that are widely available, and also the use of invertebrate protein sources like insects, polychaetes, krill, and the like this. These are going to come more on stream in the future. In terms of lipids, it's the same. At the moment, the industry is very much dependent on plant oils and the oils from the rendering industry. But in the future, more and more, we are going to get oils from, as one of our sponsors for the meeting, Corbion, from algal oils, or also from transgenic oils. The important thing when we formulate a feed, normally we consider two types of factors. On the left side, we consider the nutritional profile and safety of the product, the nutrient content, the availability of the nutrients within the ingredients, the presence of anti-nutritional factors, environmental contaminants, the physical characteristics of the ingredients. Do we need to grind them? What is their density? What is the variation in the composition? And finally, we also look at the functional properties of the ingredients, including the potential benefits in terms of fish health and disease resistance. But then also, we also have economic and market issues, and that is price. At the end of the day, it's price and market availability. Insects, yes, we like it, it's going to happen in the future, but until we start producing hundreds of thousands of tons, it's not going to make a very big impact in the short term. And then we have the market acceptability issues like fish meal and fish oil use issues, animal protein use issues, use of genetically modified ingredient issues, contaminant food safety issues, environment and climate change issues, social, religious, labor, and possible food security issues as well. All these are factors that for some countries, some markets we have to consider. But the bottom line is that we have this increasing market demand for more transparency in the feed and food production process, including traceability. In terms of the second component, feed manufacture, feed quality. Required, the need for feed plants to follow all national laws and regulations, including internationally recognized aquaculture feed standards and GMPs and BMPs. The need for feed plants to have a dedicated in-house laboratory for quality control. Again, so many plants sometimes to economize try and outsource this. It's really important to have a laboratory where you can measure the quality of your ingredients and your feeds. And finally, the need for transparency regarding ingredient use and nutrient levels on feed labels. In terms of recommendations, the need to minimize the use of mill sweepings and processing waste in finished feeds. The need for companies to establish a dedicated R&D program for the in-house testing of feed additives and new feed ingredients, and also for measuring the digestibility of the ingredients they're using in their feeds. And finally, there is also a need for feed plants to allocate sufficient funds and resources, including personnel, for data collection and technical support to farmers. We are here to support the farmer. If the farmer fails, we sell no feed. And so obviously it's important that we concentrate on that. And so within FAO, we helped develop some guidelines. This is in 2001, in the time that, just after I left actually, but it's guidelines on good aquaculture feed manufacturing practice, and the GAA, the Global Aquaculture Alliance, has recently come up with some new guidelines June of this year for feed mills. Again, these are guidelines on the do's and don'ts of how to make good aquaculture feed. In terms of R&D, I show here for Sandy, the first thing I normally do when I work with a feed company is to say, okay, where we need to have our own facility to develop our feeds, to test our feeds, to develop new ingredients, and the top photograph shows a the R&D facility of Growell. In India, they have their own indoor innovation center with tanks, and also they have an outdoor center here with cages. In Indonesia, here we have a center here, and also on the right side we have the Biomar facility in Ecuador for shrimp. Again, good feed companies, like you say, we have to do our work today for tomorrow. In terms of labeling, I just give one example of a feed company. This is a feed company in Brazil, Guabi, for example, but it's an indication of, you know, if I'm a farmer and I spend 40 to 60% of my money on feed, I want to know what's in the feed. You know, so, I mean, not precisely, but in terms of basically looking at the quality of, you know, I can tell from this about the quality of the feed. And so here you have the composition of the ingredients. I mean, in terms of the ingredients used in the feed. Underlined, I include the functional feed additives that they're adding for health reasons. The QS at the top starts for quorum sensing. So again, this is also for health concerns. Then you have the guaranteed levels of proximate composition, but also of the vitamins and the minerals. You also have at the bottom here a declaration of what ingredients are genetically modified and what genes are put in those genetically modified ingredients. It has advice on conservation, has advice on potential substitutes for the future, and also a declaration that the feed shouldn't be fed to ruminants. But again, it's important message, again, because most feed labels say absolutely nothing and gives you no idea of the quality of the feed that we're buying. In terms of on-farm feed performance and impacts, require the need for farmers to monitor and record feed intake, biomass survival, and economic FCR. Of course, good farmers should be doing this anyway. The need to store feeds under protected, cool, and well-ventilated conditions. The need to prohibit, and this is important for Asia and for many countries, the need to prohibit the top dressing of feeds with non-approved additives and ingredients. The need to optimize feed intake and feed efficiency to farm conditions. You know, the feeding rates, feeding frequency depend on water temperature, depends on oxygen levels. Each farm is different, each farming system is different. We need to optimize feed for each farm. The feed company can give guidelines, but at the end of the day, a good farmer will fine-tune their operations to suit their needs. We also need to monitor the environmental impact of feeds and minimize potential negative effects through recirculation or effluent treatment or through the use of IMTA prior to discharge. In terms of recommendations, we need to encourage farmers to establish a dedicated R&D facility for diet testing, optimizing feed management, and maintaining profitability. Not only do feed companies need to do that, but also farmers cannot also rely just on one company. A good farmer will always want to try different feeds, different additives. At the end of the day, they have to reduce their feed cost per kilo of production. And finally, we need to increase communication and dialogue between farmers, feed millers, and researchers so as to optimize on-farm feed management and profitability. A good example is, I think one of the first times I worked in India for a company I cannot mention, but one of the unique things in a lot of Asian countries, Latin American countries, is that you have little shops where they sell feeds. But also in these shops, you can also buy antibiotics. You can buy every additive in the world. And the problem is that because farmers, their main concern, especially with shrimp, is disease, anything that's going to help survival, anything that's going to help try to reduce mortality, and so you have this tendency for many farmers to top dress their feeds with additives, good, bad, and ugly. And so in the end, you know, we need to in future try and legislate that. You just need one farmer who does it in a bad way, and that affects the whole industry. And so we have to be careful. One of the things that we learned from the poultry sector is the poultry sector went indoors, and it went indoors because of biosecurity. It went indoors because of bird flu. It went indoors because we want a constant environment. We want to feed the animals 24/7. And if you do this, then you obviously can reap rewards. In aquaculture, the same trend is happening. And again, this is going to happen more and more for biosecurity concerns, the same way, to create a stable environment for the animals, but also in terms of out of sight, out of mind. It's not really in the public eye. And finally, in terms of fish quality and food safety, the need to ensure that feeds used by farmers have no negative effect on the nutritional quality and safety of aquaculture products. We are producing food. And so at the end of the day, we have a responsibility that that food is safe and it's wholesome. We need to monitor the nutritional composition, quality, and safety of aquaculture products destined for human consumption. In terms of recommendations, the need to encourage the nutritional enhancement and health attributes of aquaculture products through dietary fortification. In Corbion, you produce DHA. We can supplement the DHA content of a fillet for the consumer, as the poultry industry does in their sector. We need to promote public awareness and understanding concerning the nutritional and health benefits of farmed aquatic products. This is big and it's really important for us. We have such good story to tell, but we must get this message out. And finally, we need to encourage the use of the trimmings, the offcuts, for direct human consumption whenever possible, including the production of lower cost foods. A good example is here. We have a factory producing tilapia, but the byproducts from this product we can also use to produce hamburgers, fish balls, many different products at a much lower cost, but for the part of the population that can afford it. We can do exactly the same with salmon. At the moment, you know, it's not there yet, but it's like this again would give us more brownie points, and at the end of the day, you know, we can't basically throw away 40% of the product and just turn it into another meal. And so I've got just a few slides for concluding remarks. And that is that, you know, the aquaculture sector, particularly the cage farming sector for cold water salmonids, has received, you know, a lot of media attention in some European and North American countries, primarily due to its perceived negative environmental impacts related to visual pollution. Nobody likes to see a cage floating in the middle of a pristine loch, or due to the use of fish meal or fish oil use issues, nutrient discharge and chemical use, animal welfare issues, to issues ranging from fish escapes and the potential of the farm fish transferring a pathogen to natural wild populations. By contrast, in Asia, it's completely different. I mean, Asia already produces over 105 million metric tons of total global production. It produces over 91.76% of total global aquaculture production. But aquaculture is viewed in a much more positive sense, not only as a much needed provider of high quality and affordable aquatic food products, but also in terms of employment, in terms of increased income and health and well-being of rural and coastal communities. And so for this reason, it's embraced by most Asian countries. For sure, we have issues, but it's viewed in a much different light. And if you just look at fish consumption, globally. This is the latest data from FAO. It starts from countries like South America, where the contribution of fish to total animal protein supply in countries like Brazil, 4.6%, very low. And then it increases to Asia, which is at the top of the chart. 23% of animal protein consumption is derived from fish and shellfish products. Norway as a good example. You can see here the contribution of fish is much higher. Again, salmon is a success story in Norway in terms of the industry, in terms of employment, but also in terms of food supply. And then below here, you can see that you know, Indonesia, the second largest aquaculture producer in the world, 63% of the animal protein consumption is fish. Most of that is coming from aquaculture. It's carp, it's tilapia, it's lele, it's these fishes. Bangladesh as well. So you can see that fish has a very important role to play in terms of food security in these countries, and also in terms of the health and well-being of people. And I think this is my penultimate slide. So clearly aquaculture needs to be viewed much more holistically than just the environmental perspective that people just look at it. We have to also consider the social and economic impacts and benefits of the sector. They need to be considered in the overall long-term assessment of the sustainability of the sector for future generations. Every day, aquaculture produces over 313,000 tons of food every day. And of that food, 148,000 tons of fish, 88,000 tons of aquatic plants, 48,000 tons of mollusks, and 25,000 tons of shrimp and freshwater crustaceans. Aquaculture production is valued at approximately, according to FAO, $720,000 million per day, or $0.72 billion per day, and it currently employs about 20.5 million people worldwide. So the point I'm getting at, and this is the final slide, is apart from environmental impacts, we also have to look at the economic impacts in terms of food supply. We also have to look at social impacts in terms of nutrition and health and well-being of the community. So that's my last slide and my food for thought for a more holistic approach. Anyway, thank you very much for the opportunity for me to give this paper.
Thank you so much, Dr. Tacon, for the wonderful presentation. It was very informative and in a very simple manner. So now, actually, it is a very odd time for Dr. Tacon in Hawaii. So normally we had planned that most of the questions will reserve for the end of the webinar. But Dr. Tacon, you would like to continue after this question, and we'll finish your question and answer session right now. After that, would you like to continue, sir?
Sure. I mean,
so that accordingly people can decide whether to finish all the questions now itself.
Yeah, it's midnight here anyway, so no worries. It's okay. But I can answer if you have some questions now.
Okay. Thank you so much. And so coming to the questions, there are a few questions for Dr. Tacon. I'll just read out. So there is a question, how do you see the future for sustainable insect protein in commercial fish production in 5 years' time?
Very positive. I mean, the thing about insects is it's like fish. I mean, there are so many different species of insects. But at the end of the day, the substrate that you use to grow the insect has a big influence on the nutritional characteristics of the pupae or the product that you produce. And so, for example, if you use a seafood waste substrate, then you can get omega-3 into your product. which is obviously a good thing. I mean, I can see it, to me, I think it has lots of opportunities because in every country, everywhere in the world, we have food waste, we have agricultural waste products that we can use as a substrate to grow these organisms. Again, there's great interest, and but at the end of the day, we need to produce serious amounts of quantities of these products. When I was still in FAO, people would say, okay, can we use insects as human food? And obviously countries have been feeding on locusts and many other types of insects for generations. So I do think it has lots of potential. But other products like the algae, like the yeast, like the bacteria, which have a much faster doubling time, are probably going to beat them to the gate in the short term.
Okay, thank you. And then one more question, Dr. Tacon. How to ensure sustainable feed ingredients in ASC certification of shrimp farms?
It depends on the ASC. I'm actually on the technical committee of ASC to help develop the guidelines. So I think the important thing is that there are many different types of guidelines. ASC has one, GAA has another. They all have different degrees of requirements. ASC, I think, is probably one of the more stringent ones. Again, one of the reasons why I wanted to give this paper today is because many of the times the issue for people is the fish in, fish out issue. And so the paper that we're writing, we call it feed in, fish out. Because obviously what the industry has done since the early 80s is that the industry has doubled in size in terms of growth. The amount of fish oil, fish and fish meal that the industry uses is a lot less than it used to use. And so now it's moved on from the fish meal, fish oil issue to other considerations. And that's why I split my presentation into 4 areas: feed ingredients and formulation, feed manufacture and feeding, and the other issues. ASC is, again, it's one organization with their view on how they want their products certified. But these are only for certain markets, and every country is different. A good example is Brazil. In Brazil, the main market for their shrimp is a domestic market. And so in a sense, the important thing is that the guidelines should be for the benefit of the farmer to make more money, but also do less harm to the environment, to be more sustainable in the long term. And so this is the way I think it should be done, rather than for the certifying organization. So I didn't really answer the question, but it's...
Thank you, Dr. Tacon. And now there are 2 more questions, and I think we'll have to stop with that for the time being. And then later at the end of the webinar, maybe we can handle more questions for Dr. Tacon because of the paucity of time. We have scheduled only 5 minutes for question and answer, actually. So, yeah, the next question is, do you think prohibition of feed ingredients from the same species of good practice in terms of economic issue? In terms of sustainability, we should encourage circular economy. Do you think an approach to have the minimal level of hydrolyzation of protein of the same species to feed ingredients still allowed in EU legislation?
No, again, it's just from a nutritional point of view, the best thing to feed a shrimp is a shrimp. But if I have shrimp that are dying from EMS or white feces disease, and I'm grinding the heads and I'm putting it back in the feed, it's a problem, okay? In terms of biosecurity, in terms of, in your company, you extrude your feeds, which is good. Your temperature is much higher. You can sterilize your feed really well. You can pasteurize it. In a normal pelleting process, you cannot do that. Again, the point of view is from a nutrition perspective, there is no problem. But from a potential disease problem of whether it's a virus or whether it's a parasite or whether it's a bacteria, it's a potential problem. And in our shrimp sector, for example, every year we have a new disease coming on the market. You know, and so that's why we have to somehow come to terms with it. But like you say, in some countries, it's allowed. In the United States, it's allowed to feed a chicken to a chicken, even if it's diseased. In other parts of the world, in Europe, it's different. So, but the important point is that it's strictly from the point of view of biosecurity. In terms of the new BMPs of the new guidelines from GAA, hydrolysates are excluded because in theory there's more destruction. You know, there's no potential of a live organism getting through that process because of the acids used. But I just think that at the end of the day, we have to put biosecurity safe, you know, as a major issue.
Right, sir. So just one last question, Dr. Tacon, and then we'll move to the other presentation. I would request Dr. Tacon to kindly respond to a few more questions which are there in the pipeline, if possible, through the question and answer tab provided on the screen. So the last question is, yeah, before that, let me just share with you, we have close to 300 participants right now, which is a very good number. And I would request all the participants to answer the poll questions in the giving their valuable feedback, which you can see on your screen in the poll section. Then last question, Dr. Tacon. What will be the limitations in using insect meal?
I mean, I have not worked directly with insect meal but from the published literature, again, it depends on the substrate that we use and the species, but they have a very high lipid content. Okay, you're a feed manufacturer. You know that as a feed manufacturer, managing ingredients which have a 30% lipid content is not easy, and so there are limitations in terms of handling. Depending on the species, you're going to have chitin. You're going to have a proportion of the nitrogen is going to be formed in the form of N-acetyl hexosamines. It's going to be in form of chitin, which is not as, it's like a shrimp. It's not as digestible as other fractions. So this might be a limiting factor. But I think it's very promising. But I see that just those two things being, the lipid content can be quite high. And so we might need to defat the meal, and then we produce a product that's very high in protein. At the moment, the price of lipid is more or less twice the price of protein, and so those lipid ingredients and what's in the lipids is going to be really, really important.
Okay. So, okay, thanks a lot, Dr. Tacon, for the wonderful presentation.
No, pleasure.
Once again. So, before going to the next panelist, I would like to remind all the participants that you can ask questions and share your comments, views through the question and answer option of the Zoom platform. Most of you are aware about this. And for easier interaction, please mention the panelist name to whom you want to interact. We'll take some of the questions after each of the presentation, and then we'll come back to the panelists if we have enough time. And it will be appreciated if you could answer the poll questions for your valuable feedback. Just like to remind once again. Now we are moving to our next panelist from our sponsoring company, Dr. Fusi Guo, my friend. So Dr. Fusi Guo is the lead of Asia business development for the Netherlands-based firm Corbion, which is a global market leader in lactic acid and its derivatives, and a leading supplier of emulsifiers, functional enzyme blends, minerals, vitamins, and algae ingredients. So Dr. Guo holds a PhD degree from the University of Guelph, Ontario, Canada, and a MSc degree from the National University of Singapore, and a bachelor's in aquaculture from the Ocean University of China. He has been working in the field of aqua nutrition and health for over 25 years in companies including DSM, Alltech, Novartis, Bayer, and Roche. In Corbion, he is responsible for developing new businesses for Alga Prime DHA for marine fish and shrimp. He also coordinates the research initiatives and projects, formulates market entry strategy, including product, solution, channel, market segment, and competitor analysis. Dr. Fusi is going to discuss about marine microalgae as an alternative to fish oil from the perspective of feed millers and farmers. Over to you, Dr. Fusi.
Thank you, Santif. Thank you so much. So I go ahead to share my screen. Oh, what happened? Okay, give me a second. Why I don't see the
share screen?
Yeah, but
okay,
just click the share screen, but it just come up with just blank screen. Hold on. Did I close properly? Just give me one more second. Okay.
No problem.
Very strange. So Windows. Here, this one.
Yes.
Can you see my screen now?
Yes, very much.
Okay.
You can put it into the presentation mode.
Yes.
There you are.
Can you see now?
Yes.
Very good.
Very well.
So, good morning, good afternoon, good evening once again. Thank you for joining my talk. So, I was given this title to talk about marine microalgae DHA as an alternative to fish oil, and try to look at it from the perspective of the feed millers and the farmers. Okay. So, before I go into the topic, I would like to share with you just a week ago, on September the 17th, Mayo Clinic Proceedings, that's the impact factors of 7.2 journals, published the publications entitled Effect of Omega-3 Dosage on Cardiovascular Outcomes. And the paper, as I put it in the summary here, provide compelling evidence that consume omega-3 DHA EPA from seafood is an effective strategy to prevent cardiovascular disease, CVD. Yeah? They use meta-analysis. So it's the most comprehensive analysis today to study the omega-3 dosage on CVD prevention. So it involved in-depth review of 40 clinical trials. And the summary is like this. It said the intake of omega-3 EPA DHA is correlated with reduced risk of coronary heart disease, the CHD event, which has killed 7.4 million people globally annually, and reduced the risk of myocardial infarction, also the commonly called heart attacks. So DHA and EPA supplementation is associated with 13% reduction in risk for heart attacks, 35% reduction in risk for fatal heart attack, 10% reduction in risk for CHD events, 9% reduction in risk for CHD mortality. So the paper continue, say the benefit of omega-3, DHA, and EPA for cardiovascular health appear to increase with dosage, meaning you take more, for instance, take 100 milligram per day more, you'll decrease the risk of CVD and heart attack by close to 6%. And the researchers has considered that dosage up to 5.5 gram per day. So that's you're taking like 5 fish oil tablets a day, equivalent. So the GOED, that's a global organization for EPA and DHA omega-3, said that an optimum way of omega-3, DHA, EPA intake is through eating fish, particularly fatty fish like salmon, anchovy, and sardine. And World Health Organization, WHO, recommends that 200 to 500 milligram per day of omega-3, EPA, DHA, or 1 to 2 serving of oily fish per week. But the problem is the omega-3 level has dropped in farm salmon. And again, this is the publication in Nature, in a very high impact factor journal. In 2016, that the group of researchers analyzed the salmon found in Scotland, and they study the impact of sustainable feed on omega-3 long-chain fatty acid level in farm Scottish fish from 2006 to 2015. So you see on 2006, the omega-3 level is like 2.8 gram per 100 gram of fillet. 10 years down the road, 2015, it became 1.3 gram per 100 gram of fillet. So that is a 54% reduction over 9 years. And why is a reduction of omega-3 in farm salmon? It's because modern salmon feed formulation are low in long-chain omega-3s. And this is a publication from Mowi, one of the biggest salmon feed and farm company in the world. Just look at 1992. The majority, 65% of salmon feed is made of fish meal and 25% of fish oil, 24% of fish oil. Only 11% are vegetable proteins or vegetable raw material. 10 years going forward, by year 2000, fish meal has reduced almost half. Fish oil, on the contrary, increased to 31%. And the reduction of fish meal is compensated by vegetable proteins. So fast forward to last year, the majority of the salmon diet is vegetable protein, vegetable raw material, 76%. Fish meal, only 13%. Fish oil, 10, 11%. And that is why causing the reduction of omega-3, long-chain omega-3 in farm salmon. Okay, so another information from IFO, the Marine Ingredients Organization, is that for the past 25 years, the production of fish meal and fish oil has been relatively stable at about 5 million tons for fish meal and 1 million tons of fish oil. So the two pie chart here, you can see fish meal, 75% of fish meal has been used in aquaculture. And for fish oil, also about 73–75% are going to aquaculture. So this is 2018's number. So have these two number, the 1 million tons of fish oil, keep it in your mind. So later we'll refer it back. So the FAO 2020, the State of World Fishery and Aquaculture, showing that the capture fishery has been stagnant. That is the similar information to EFOS. Yeah, for the past 25 years, capture fishery as the orange in the chart, so it's been stagnant. However, the aquaculture is growing. You can see this. The darker blue is a marine aquaculture, the lighter blue is inland freshwater aquaculture. At the same time, the human population is increasing, and it's going to continue to increase, 1 or 2 billion over the next 2 decades. Fish as food also increase. Look at this steep curve. And the per capita apparent consumption of fish also increasing. And these are from the latest statistic from FAO 2020. So the fish oil supply and the demand, there's a gap, quite a huge gap. Right now, fish oil roughly about 1 million tons, as we said earlier. But the 1 million ton with about 30% coming from byproducts, from the recycle, reuse, from the animal seafood processing plant. So in actual supply of fish oil from pelagic fish or foraging fish from the ocean is about 600 to 700,000 tons. So, but the demand is more than 1 million. So the gap is at least 400,000 metric tons right now, the gap, yeah? Going forward to 2050, the gap will be even larger, going to 600, 700 tons. So the industry desperately need a new source of long-chain omega-3 to grow the aquaculture responsibly and sustainably. So let's look at the fish oil price. It's very volatile. So this chart shows the fish oil and soybean oil prices in Netherlands for the past 40 years. You see, from 1984 until almost 2011, fish oil price almost the same as soybean oil. And it go up and down as the same pattern as soybean oil too. But by 2011, the fish oil price start to increase. And most recently, during the COVID-19 pandemic, look at the chart on the right-hand side. These are by week. So fish oil price has been around 2,400 for the COVID time from March to May or June. And it comes down a little bit right now, about $2,100 per ton, FOB from Peru, yeah? So fish oil price is very volatile and the supply is limited. So we definitely need new pathway to produce omega-3. So traditionally, omega-3 DHA EPA is produced by the marine microalgae, like Cichochytrium or Orantochytrium. And this microalgae is eaten up by zooplankton, and the zooplankton is eaten up by crustacean or small fish, filter feeder fish. And this fish has been harvested by fishing vessels and make it into fish oil. And this fish oil are putting into the feed to feed our marine fish or marine crustacean. So the new pathway is we directly take the microalgae and cut all the middle stages using heterotrophic, using fermentation technology directly to produce algae, and with high fat contents and high long-chain omega-3 contents. And this could be produced in a matter of days instead of going through the long supply chain. So just to give you an idea of the factory that we have in Orinjuva, Sao Paulo state of Brazil, this fermentation tanks is more than 600 tons. It's like a beer tank. You ever pass by a beer factory? I pass by almost every day a Carlsberg factory in Kuala Lumpur. You'll see the beer, this kind of fermentation tank outdoor, and you're making beer. In this case, we're making Cichochytrium algae.
Just
So we are growing algal DHA at a scale today. Briefly, just showing you the flow chart or how we produce the microalgae. And the important things here I'd like to point out is we produce microalgae in a very sustainable way because we use energy coming from renewable source, such as while we use sugar coming from sugar cane to feed to the algae to grow them. And sugar cane, when you press out the sugar, you have the sugar cane waste, and they were sun dried and further become a burning material for generating electricity of our heating purpose. So that is why our production cost for our microalgae is relatively low. And we also have low carbon footprint, and these are all rainwater fed, low water footprint, low land footprint as well. So, and this the Schizochytrium, the microalgae we use, is a non-GMO, and the sugar we use is also from non-GMO feedstocks, right? So, coming into how much long-chain omega-3 needed for Atlantic salmon or for the marine fishes that we are growing. And this directly taken from NRC, from the National Research Council, 2011. The quantitative requirement of long-chain omega-3 for Atlantic salmon typically is 0.5 to 1%. To one that more related to us, the red Seabream is 2.1%. And these are for larva and early stage of, and in the early stage, they need more. For yellowtail, you need about 4% of long-chain omega-3. So fast forward to juvenile or adult, sub-adult. Oops, let me go back a little bit. Okay, for European sea bass, you need 1% of long-chain omega-3. For grouper, which is quite a popular species in Asia, Southeast Asia, also need 1%. For red sea bream, popular in Japan, 0.5%. And for yellowtail or kingfish, quite a little bit higher, 2 to 2.5%. Yeah. So I'm going to share with you some of the data we have showing that the algal DHA is highly digestible by salmon. Over 98% digestibility. And this trial was done in California, looking at the ADC of our algal pine through dosage from 5% up to 30%. It's very high concentration, right? So next one. Algae DHA biomass has been proven to be good for salmon health. And this is a recent publication by my Noviva group of researchers in Norway. They look at the microalgae Schizochytrium biomass, improve the growth and fillet quality. So the results is they concluded that there are more omega-3 retained in the fillet and also support better growth. They have better body weight, even with similar FCR, but with a better survival rate. They also found that the salmon fed with omega-3 from microalgae has better fillet pigmentation. And this is an add-on benefit because right now consumer prefers the red or the orange red salmon. If the salmon appear like grayish color, it's not good salmon. So this is the consumer perception. So why they have a better fillet pigmentation? We all know the pigmentation is caused by carotenoids or specifically astaxanthin. And astaxanthin is a fat-soluble substance. And omega-3, they are fat, so they are fatty acids. So that's why you have better fatty acid profile. In the fillet, you are sure going to have a better pigmentation. Yeah. They also found less prevalence of melanin spots. And melanin spots will degrade the carcass quality. So you have basically one stone, 3 birds, putting algae DHA in the salmon feed, you can achieve so many benefits. So that's salmon or marine fish. How about shrimp? What's the quantitative requirement? Once again, NRC 2011. For Pacific white shrimp, that's very popular globally, as well as in Asia. It requires 0.5% of DHA or EPA. Black tiger, the monodon, need higher, almost double, 0.9% of DHA or EPA. The Chinese shrimp, they need 1%, and kuruma shrimp, the japonica, need 1.1%. And these are the original paper. I took it from here. And this research had been done almost 3 or 4 decades ago. So these are basically very established data. And looking at shrimp, as we said, it needs about 0.5 to 1% of long-chain polyunsaturated fatty acids. We all know fish oil used in shrimp feed is relatively low compared to salmon. Yeah, typically in the level of 1 to 5%. Just looking at this chart below here, these are from USDA and Rabobank 2020. The one that we blue circle is the fish oil used. Indonesia shrimp feed typically have about 5% of fish oil, according to and Indian Venomite basically did not put any fish oil, but I kind of wonder as well. But notice that they have 30% of fish meal in the diet. So, you know, fish meal have residual oil, 6 to 8% of fish oil. So they partially meet the requirement for fatty acids. So that could be why, explaining why Indian shrimp feed do not need so much or do not need inclusion of extra fish oil. Yeah. So the benefit of algae DHA for shrimp farmer found that the algae DHA has marine algae smell. So when you replace fish oil and put in algae DHA, algopine DHA, the shrimp actually very happy to eat it. Yeah. So substituting fish oil with algopine DHA doesn't change the smell of the fish of the shrimp feed, and the shrimp have shown to have good consumption of the feed and also maintain the growth or even improve the growth. Yeah. So I have a very short presentation today. So I'm now coming to my conclusion already. So we had talked about the publication that will appear in Mayo Clinic last week, so showing compelling evidence that consuming more omega-3 EPA DHA can prevent cardiovascular disease. And omega-3 level in farm salmon has dropped by more than half in the past decades. So supplementing with algae omega-3 is a strategy to reverse the downward trend. With rising demand for fish oil and limited sources, sustainable omega-3 for microalgae dialgopine DHA is an excellent alternative. So, algopine DHA is highly digestible, as I show you in salmon, which is carnivorous. The digestibility is over 98%. And because algopine DHA in Asia, we have the powder version. It's very easy to use and very easy to do reformulation with. And algopine DHA is the proven viable fish oil alternative, and it's getting wider commercial adoption by feed millers and farmers in salmon, in shrimp, and in marine fish. So that concludes my talks. Thank you very much. Welcome any questions. Back to you, Sandeep. Can't hear you, Sandeep.
To unmute it. Can you hear me?
Yes.
Yes.
Okay,
Yes.
Now
sorry.
we can hear you.
Now it's okay. So this was an excellent presentation from Dr. Fusi, and I hope all the feed millers as well as the shrimp farmers and fish farmers will be benefited from your presentation. So now we'll go for a few questions, and then we'll move to the next presentation. Before that, may I request Dr. Tacon, if possible, you could kindly answer some of the many questions are there for you. I don't know whether we'll have sufficient time at the end of the webinar. So I would request you to kindly respond to the questions through the Q&A window. Thank you so much. I'm sorry to bother you. Okay, now we'll go to the questions for Dr. Fusi. The first question is related to the recent news that a company made a feed using plant-based ingredient for salmon. How do you see the future of plant-based ingredients in fish feed? Dr. Fusi.
Wow, that's a good question. Land-based salmon. Well, basically, we also call IAS system, and basically it's a intensive care, an ICU system for fish, and for salmon, I must say, it's quite established because the early stage, especially the hatchery nursery stage of salmon culture, is actually on land, and so they just increase the carrying capacity to grow the fish from 100 gram to 5 kilogram. And they're having a lot of hot money coming into the industry, coming in to fund this industry. I think it's going to grow because with that kind of investment coming, and that could be a game changer. I read that they were saying they're going to close to 1 million tons of salmon will be coming from land-based farming. They may be too optimistic. It may take more than 2 years to get to the level. So because for land-based culture, basically water quality requirement is very high. And for the water quality requirement, the high water quality requirement, meaning you need to have a very good feed, highly digestible feed. So all the ingredient used to manufacture feed has to be optimized and digestible and absorbed by fish or shrimp, and become less waste being put into the system. So I'm very hopeful, very excited that Algopime DHA can contribute to this development because it's highly digestible, as I show you, more than 98%, leave very little behind. And so hopefully, did I answer the questions?
Yeah, I think that answers the question. Okay. And then next question is the increased use of vegetable raw material in salmon feed result in reducing omega-3 long chain fatty acid levels?
Yes, in 1990, 30 years ago, they are like, wow, 30% of fish oil. I mean, right now, salmon feed is still very high, still has very high fat contents, 30 to 35%. But with the 30 to 35%, 30 years ago, all of that is fish oil. But now, 25%, 20 to 25% has been changed to vegetable oil. Only 10, 11% is fish oil. So what you eat is what you get. Vegetable oil do not have long-chain omega-3. They do have ALA, the alpha-linolenic acid, but they do not have long-chain omega-3 like EPA, DHA. So they're directly contributing to the reduction of omega-3, long-chain omega-3 in the fillet of salmon, as well as other oily fish or oily marine organisms.
Okay. So another question is algal-based PABA and GABA influence the growth of shrimps?
What is BABA or GABA?
PABA and GABA.
I'm not sure I understand the question. BABA?
Okay, we'll ask
Okay.
the participant to sort of elaborate on his question, and then we'll come back to you. Maybe at the end of the webinar.
Okay.
So,
yeah. Also can email me. Yeah.
Yeah, I think that's much better. Yeah. Then the last question we'll take, then remaining will shift to the end of the webinar.
All right.
Well, yeah. What about the findings of algal oil for warm water fishes?
What are the findings?
Yeah, of algal oil for warm water fishes.
Say for warm water fishes in this area will be sea bass, also called Barramundi, or groupers. And sea bass, typically right now, the industry or the feed mailer is including fat level of 12 to 14%. It's quite high. But they cannot go even higher, even though they are benefits. Why? Because if they spray oil post extrusion and they do not have a vacuum coater, as you know, most of the Asian feed mill do not have a vacuum coater like salmon feed mill, because vacuum coater is very costly and it also slow down the manufacturing process. Usually it's a batch handling. So consequence, they couldn't spray too much oil because no vacuum to suck the oil into the pellet, into the extruded pellet. The oil will leak out, especially in the warm climate in Southeast Asia and for the warm water fish. So typically you will see the oil will come out from the pellet, and you can see on the feedback, the oil just come up and it's very greasy. And when you throw into the water, the cages or the pond, a layer of oil film will float on the surface, and that is not good. The good news is our algal DHA is in powder form, so you can add actually whatever you like. It's still encapsulated by the cell wall of the microalgae, so the oil will not come out. So that will be a great news for the development of a high energy pellets, especially for sea bass or for grouper.
Okay, thank you.
All right.
And then there are a lot of questions coming in for Dr. Fusi, just like Dr. Tacon. So I would request both of you to kindly respond to them to the question answer tab. And just we'll take the last question now, right now. What is the forecast for the replacement of algae DHA for fish meal in the next 5 years?
We are not replacing fish meal. We are actually supplementing or substituting fish oil. Because fish meal is protein, yeah, and they also have some fish oil inside, 6 to 8%. So as you see in my presentation, the fish oil coming from forage fish from the ocean is about 1 million ton, and it's stagnant, yeah, and it's decreasing in the future, and price could go up. It's very volatile. So we foresee most of the salmon feed mill and farm will adopt this technology as we going more efficient in our production, as we bring our price down more to help the industry. Because right now, algae biomass or algae oil is still more costly than fish oil, yeah, relatively, yeah. But if you compare on a per omega-3 basis, we are almost on par due to our enormous scales of production, yeah. So the more adoption of this technology will make us more flexible to increase our production and to bring the cost down even further. Yeah, so I see a big future, especially for the land-based salmon farming. They need good ingredients, and algal DHA is one of them.
Okay, thank you.
Thank you, thank you, thank you, Sandeep.
Thank you, thank you. So with this, we'll end the question and answer session for the time being, and we'll move to the next presentation. So our presenter is Miss Runa Hogg Khoury, Director Sustainability and Public Affairs, Aker Biomarine AS, Norway. So Ms. Runa leads Aker Biomarine sustainability team with experience in sustainability, both from the business sector and the non-profit sector on national and international levels. She previously led the team of a former consultant of DNVGL. Ms. Runa is a graduate of both the Norway, specializing in business strategy and environmental politics. Ms. Runa believes in driving environmental change from the inside of business. Aker Biomarine steps forward and takes a clear stand to drive the industry in a sustainable manner. Today, Ms. Runa is going to present on Antarctic krill, the sustainable alternative for aquafeed. Over to you, Ms. Runa.
Many thanks. Can you hear me?
Yes, yes, very clear.
Hello, everyone. Very happy to be joining you from Oslo in Norway and to be giving my presentation on Aker Biomarine's work and krill. Let me see if I can now share my screen. Is this visible to you all?
Yes, yes.
Many thanks. Okay, so my name is Runa Hogg Khoury. I'm the Sustainability Director of Aker Biomarine, a Norwegian krill harvesting and biotech innovation company. Today I want to talk about how Antarctic krill is one sustainable alternative for future aquafeed formulas. So just a very short introduction on Aker Biomarine. We are a company with a vertically integrated value chain. So a complex company, but from a sustainability point of view, this is a big blessing and really also a competitive advantage because we can work on improvements throughout our whole value chain. So we have 3 harvesting vessels that fish krill in Antarctica. They also process the krill directly on board. So we can actually keep the quality of the meal. Then we have logistics hubs in Montevideo in Uruguay. And we then ship the products from Montevideo through to our krill aqua customers. So this is the krill aqua value chain. We actually have 3 product lines. So we have the Superba krill to your right. That's a pure krill oil product that is directly for human consumption, processed at our plant in Houston. We have the krill aqua meal that I will particularly talk about today, going to the aquaculture feed formulas. And we also have a small line going to pet feed. A little bit like Dr. Fucci, I would like to start by reflecting a little bit about how we all fit into this bigger megatrends, being part of the aquaculture value chain. So in Aker Biomarine, we are quite concerned and we see our business development into the 2050 perspective, the long-term perspective, when we know we will be about 10 billion people on this planet. We know also that we will need to produce about 70% more food than we do today to feed this population. And we are very concerned about this fact that farmable land cannot sustain this 70% growth. And we quite frankly feel that this is a slightly under-communicated point in many parts of society today. Farmable land is already under a lot of strain. This has to do with access to land. It has to do with CO2 emissions from land-based food production, direct or indirect. It has to do with access to fresh water as an input factor. For those of you going into the science, you know the International Panel on Climate Change, IPCC report from 2019 went into this climate change and the land, looking at land-based food production, clearly stating that even with all the innovation we will see on officiating land-based production, farmable land alone cannot sustain a 70% growth. So in the bigger picture, we see an urgent call for a global food system that uses less energy, emits less CO2, and uses less fresh water. Today, most human food comes from land areas. This is a bit of a fun fact. Actually, only 2% of the proteins today are produced from the ocean or marine sources, which is quite an astounding low percentage. So we firmly believe that we need to harvest the oceans more. The oceans represent 70% of the planet, yet only 2% of protein is harvested from there today. So we see a clear role for a sort of sustainable harvest of the ocean. And we firmly believe that seafood is one important solution to future food and nutrition security. We also believe that scaling up aquaculture is essential to secure future food supplies. In their 2018 blue paper, The Future of Food from the Sea, this high-level panel for a sustainable ocean economy argues that under optimistic projections regarding alternative aquaculture feed and innovations and uptake, the ocean could actually supply 6 times more food than it does today, reaching 364 million metric tons of animal protein. So this would actually represent more than 2/3 of the edible meat that the UN FAO estimates will be needed to feed the future global population. So there's a large and substantial unleashed potential as we see it in future marine food supplies if we manage to scale up a sustainable aquaculture. And this is another important factor as we see it, that aquaculture delivers very well on the need to reduce the impact of global food production with regards to climate change. So here we have been looking a little bit at the carbon footprint of various food products. As in kilos per kilos produced, you see beef, obviously no surprise there, has a very large carbon footprint, but have a look at the farmed salmon. It comes out very beneficial on this, to this end. And then another important point here is that innovation in feed is obviously a trigger to unleash growth in aquaculture. So aquaculture is in very rapid growth worldwide, as we all know. However, to unleash this full potential of aquaculture in the decades ahead, we believe that advances in innovations in aquaculture feed is a key depending factor. So this is about ensuring enough capacity of new raw materials with low environmental footprints. So identifying the most sustainable and low impact compositions. And we believe that this will require a palette of different solutions. So back to Dr. Fuji's presentation on algae, we truly believe that's one solution, but also we see krill as another sort of puzzle piece into this future. We also believe, as I've written on this slide, that life cycle assessments on feed ingredients will constitute an important denominator going forward. So for example, here at Aquaculture, we are in the process now of updating our LCA of our life cycle assessment, or the sort of individual carbon footprint of each of our products lines, including the krill aqua meal. And here is the hero of our story, the krill. We believe that krill is one puzzle piece into future sustainable feed formulas in aquaculture. So krill is one of the most abundant species on Earth. Actually, fun fact, supposedly there is about twice the volume of krill on Earth as there is biomass volume of human beings. So krill is in the oceans everywhere, but it's particularly dense in Antarctica, which is an area of the world where there are not so many various species. So this is also a very good place to harvest the krill, because bycatch is very, very low in this area. Also because we have introduced some technologies of that at our own vessels, but this is a good place to harvest krill. Krill is placed at the bottom of the food chain, so it feeds on plankton. So it's a very kind of clean source, has very low levels of dioxins and dioxin-like PCBs. So obviously, we operate in Antarctica, and with this comes a great responsibility to do things right. And we are very passionate about doing things right. Sustainability has been sort of a prerequisite for our entire business model, and it's also something that we are very passionate about in our company. If you have a look at this little map I've shown you here, you see the area 48. That's the part of Antarctica where we are allowed to harvest, and it's called Area 48. And compared to other fisheries, where the United Nations typically define a sustainable catch level in a fishery at 10% of the local biomass in the area. Whereas for Antarctic krill, this is very strictly regulated, and the quota each year is set to only 1% of the krill available in Area 48. And this is a very important point, because obviously the harvest of krill needs to live very responsibly alongside the rest of the ecosystem. So this leaves 99% of the krill stock also in Area 48 for other predators such as whales, seals, penguins. Can also mention that this quota is set by CAMELAR, the convention CAMELAR, that is that regulates Antarctica, and that is a convention of 26 different countries that all have interests in Antarctica, and they meet annually to sort of manage this this area. Now, we obviously rely heavily on science, and science documents a healthy krill biomass. So every year there are some synopsis studies done, but there was a very thorough one done last year in 2019, showing a slight increase in the estimate of krill in Area 48 where we harvest. So basically what this tells us is that the krill biomass remains healthy and alongside the harvest activity in the area. Here again, just underpinning this quota. Another important point for us, obviously, is third-party certification. So I'm sure you are all familiar with the MSC, which is kind of the fishery equivalent of the ASC. So we have had our MSC certification since 2010 for our aquabiomarine's value chain and the fishery in Antarctica. Actually, we just got our third certification through today, still with very good scores, so that is very good. We also have the Friend of the Sea third-party certification, and then I want to particularly highlight Sustainable Fisheries Partnership. So this is an independent NGO. We never have like any direct interaction with them, but they kind of monitor the state of global fisheries. And for 5 succeeding years, they have been looking at the A rating, the Antarctic krill fishery, as the most sustainable of all reduction fisheries. So basically reduction fisheries is what goes into fish oil and fish meal. Lastly, I want to just briefly comment on some sustainability effects of the feed formula. So various science studies has documented that blending krill feed into formulas enhances fish growth and quality and reduces waste and supports a more efficient feed. So this is a little bit more detail about our Antarctic krill as it goes into the krill meal. So krill meal is intended to partially replace fish meal. That's how it's introduced into formula. And the krill meal composition is almost identical to fish meal when it comes to dry matter, ash, and protein contents. And what is important is how much of EPA and DHA gets into cell membranes. So the tissue is the issue. And that the omega-3s are linked to phospholipids in krill oil is in contrast to the omega-3s in fish oil, where they are limited to triglycerides. So triglycerides can be used by the body as energy and store in fat, meaning that some of the omega-3s are lost before they are integrated into cell membranes. So on the other hand, the fact that we have these phospholipids that can be directly integrated into cell membranes is a phospholipid bilayer. So this is one of the important sort of scientific, apologies, still back to this one, effects of our of the krill as a functional ingredient. And then going back here, we obviously have a very active science team in Aquaculture, and what has characterized Aquaculture's krill harvest is that this was a completely new marine ingredient. And we have developed it from the outset, all the way from the harvesting through to processing it into new product qualities, into new product lines and new applications. And we spend a lot of time and efforts also documenting the effects, as I'm sure you are also doing with, for example, algae. And what our science shows us, which is also, I would say, very important from a sustainability point of view, is the benefits of replacing fish meal with Antarctic krill meal in diets for marine and freshwater fish. We have seen positive effects on both disease resistance. In this example, we are using the Seabream. Also on the omega-3 level in the final fish produce, on skeletal mineralization, hepatic utilization, hatchability, and performance of the fish. So we see a lot of benefits adding the krill into aqua formulas in terms of being a very functional feed ingredient. Yes, here we are understating the effect of omega-3 phospholipids as a more efficient transporter, actually, of omega-3 into the body. And this goes for human bodies through krill oil, but certainly also something we have seen documented when introducing krill into aqua meal. That the omega-3 is transported more efficiently into the fish. So for most of the fish and crustacean species, the estimated phospholipid requirements of larvae are in the range of 1 to 3%. And that was the last slide that I wanted to show today. And I just want to open the floor for questions, actually. Mr. Sandeep, I'm afraid I can't hear you. I think you need to unmute.
Sandeep, you are muted. Can you please check your microphone?
Yeah. So yes, there we are. And thank you very much, Ms. Runa, for your profound and detailed presentation. And I think questions, if it's okay, we'll keep it for the end. Is that okay?
That is fine for me.
Yeah. So
Sandeep,
yeah, please.
Sorry,
yeah,
Sandeep, you can go with the backup questions. No problem. Please go ahead.
Okay. Fine. So, one second. The one question I would like to ask Ms. Runa, will krill fulfill its promise as a sustainable aquaculture feed ingredient?
Yes, we firmly believe that it will. I mean, krill is one of the largest biomasses on Earth, as I stated. The harvest is very strictly regulated. And we don't see anything changing in that going forward. I mean, it needs to be a strictly regulated harvest, but we certainly it remains science-based. We stand very comfortably in this remaining a long-term fishery that has been, I mean, as I said, it's been rated one of the most sustainable fisheries in the world. So it is very well managed. So we truly believe in the long-term perspective of this fishery. And in general, I mean, if you look at the longer term perspective here, we believe that we need to think in new ways about future food systems, and that we will see a lot of innovation in both nutrients and food. And we believe that we will see new marine resources being developed in this way as one important part of that, obviously also into a growing and sustainable aquaculture.
Okay, thank you. There's one more question. According to CCA MLR guidelines, there are annual quota limits on the overall krill harvest. Do you think it will impede the sustainable supply of krill products?
Well, the krill quota is set at 1% of the biomass in Area 48. The fleet today, the entire global fleet is 11 vessels from various from various countries. Aker BioMarine is the only Norwegian company harvesting. We have 3 vessels today, and we harvest about 70% of what is total catch per today. Actually, there is still room for growth within that 1% quota. So, for us today, it's actually not about, we harvest more than enough to keep growing. So it's really, you know, as I was saying, we are kind of a pioneer in this area, and it's really more about us developing the products further, enhancing that kind of value chain that we have. But we also, as we are developing product lines also directly for human consumption. But we don't see that a barrier whatsoever for our future supplies into aqua now.
Okay, thank you. So I hope most of our audience must be aware that apart from the feed millers using krill meal in the formulations, especially for the value-added feeds, many of our shrimp hatchery operators also use frozen krill as a food, as a feed for their brood stock, especially. So that is also another use of krill, which is found to be very useful. Okay, now we move to our last presentation, last but not the least, by our friend Dr. Kabir Chowdhury from Canada. So I'll just introduce Dr. Kabir. Dr. Kabir Chowdhury has been involved in the aquaculture and aquaculture nutrition for more than 2 decades and trained in Bangladesh, Thailand, and Canada. His academic and research excellence are reflected in numerous scientific and popular articles published in all major aquaculture journals and magazines. After completing PhD from Fish Nutrition Research Laboratory of the University of Guelph, Canada, and a brief stint as postdoctoral fellow at the same institution, he joined Chefo Nutrition Incorporated of Canada as the Global Technical Manager of Aquaculture. In fact, last year, exactly 1 year ago, I happened to be in Canada. So Dr. Kabir was kind enough to, to show me around the wonderful facility they have. Jeffo has very near to Montreal. So anyway, now in this role, he leads activities related to providing nutrition-based solutions to the aquaculture industry. The solutions designed to assist enduring economically and environmentally sustainable development. Since 2019, he is managing overall business of Jeffo in South Asia as a sales director South Asia. He also manages a LinkedIn-based professional group which is called ANN, Aquaculture Nutritionist Network, a group of 2,000 plus members. And recently, ANN initiated an internationally acclaimed monthly webinar series that is Talking with the Titans jointly with Jeffo. Now, Dr. Kabir is going to present the role of functional additives in aquafeed toward sustainability. So over to Dr. Kabir.
Thank you, Sandeep ji, for the introduction, which may be too much for me. But yes, I would like to thank the organizer, InfoFish, and InfoFish team, as well as you as the moderator and the whole panelist, and the attendees. Today we still have close to 260 attendees listening now. So rather than talking about a product or things, we will discuss mostly about the additives. We will try to define the functional feed and additives at the beginning, and then we will go through different kind of additives that have functional properties, including amino acids, vitamins, minerals, etc. Okay, so let's move toward this. I just noticed this this news last week, and even during this whole pandemic, there is about $1.5 billion invested into alternative protein sources. And if you go further, out of this $1.5 billion, $435 million has been invested into fermentation technologies that use microbes, microalgae, or mycoprotein. And that's to produce biomass, and as well as to improve plant proteins. And as we know, as co-products from these new fermentation technologies, we can get a lot of functional ingredients. I could go on and on this, but this is a new trend. I would say that through fermentation could be the future. Okay, for us as you see from several previous presentations. In this article, it says at least 44 startups focused on alternative proteins worldwide. I put a question mark because I was investigating insect meal producers globally, and what I found is there are about more than 400 insect protein meal producers worldwide, small or large, and more than 50 major, like they are targeting more than 10,000 tons a year, about 40 insect protein meal producers. So this is a big industry. It's going to be a big industry, the alternative protein sources in the future, including algae and insect meal. Those could be the two driving forces as you see in future. So in terms of functional feed, this is a slide from a presentation we made in 2015, one in TARS, another one is USAID Shrimp Feed Conference, where we talked about the concept as functional feed or additives in 2015. And today, after 5 years, I think there are several companies are producing functional feed. As we know, Growell also has a functional feed, Spreading has functional feed for a specific purpose. Now going to the presentation. So the presentation is 4 parts. In the first part, we will try to define what define functional feed and functional feed additive, and then why we need them, the different types, and at the end, just one slide, the cautionary tale, because there's always a lot of hypes. We are talking about algae meal, we are talking about insect meal. We need to go a long way in terms of processing these raw materials to remove some anti-nutrients or remove some properties which may affect the growth or digestion of these raw materials. So we need to standardize these protein sources that we have, or in this or in some cases the oil sources that we have, the new oil sources. We need to standardize the quality of these sources. So we need to go some more miles before they become really mainstreams. Okay. So now coming to the definition, defining functional. So what is functional feed? The feed that serves a specific purpose beyond basic nutritional requirement to promote health and stress resistance of the animals, right? And I put a stress resistance because in farm conditions, animals are always under some kind of a stress, right? It could be crowding stress. It could be when we transfer from one environment to another, or from one tank to another tank, or we sample, we induce stress in the animals. So we need to manage this stress in the animals properly, right? To facilitate better performance as well as better welfare of the animals we are raising. Okay. And now coming to the functional additive. So functional feed cannot be produced without functional additives. Okay. So the additive is the same that serves specific purpose beyond basic nutritional requirement. Okay. Coming to specific why we need them, right? Why we need these functional additives. As I mentioned in my earlier slides, that animals are always under stress, and health and disease is one of the issues, and pathogens are always in the environment, right? And then hosts are our target animals are the host, and when specific pathogens, the population of specific pathogens increases a lot, or environmental changes, animals are under stress, and we see the manifestation of disease. So the disease is actually manifestation of the issues and problems we have in the environment. The environment could be feed as well, right? What we are providing to the animal. So if animals are under stress and then environment is not good, then we see the manifestation of disease, all right? And there are different kind of stress. There are social stress, there are like crowding stress, there's environmental stress, it could be oxygen level, it could be ammonia, nitrite level in the water, it could be feeding and management stress as well, and the pathology of the animal, okay? And in terms of oxidative stress, and you can see there's endogenous sources and exogenous sources. Endogenous sources could be immune system can be compromised, so we need to work on that, because if we look at the genetic improvement of the animals, especially in terrestrial animals, right? When you focus on growth genes, we sacrifice some other genes as well, right? So some immune genes are normally poorly expressed when we focus on the growth genes. So immunity is one of the issues that can be that should be look at when we raise our animals. Okay, so there could be metabolic stress. There are exogenous sources. There are radiation, chemicals, and pathogens, right? And there are negative effects and positive effects of this. So when they're under stress, they produce reactive oxygen species, right? Under oxidative stress, there are negative effects as well as some positive effects, but negative effects sometimes are overly manifested when the severity of stress is much higher. Okay. And now going forward to the specific types of additives, functional additives, functional feed additives. We'll talk about amino acids, vitamins and minerals. We'll talk about membrane active peptides, macroalgae. We'll have some few slides on this pre, and there's a new term coming out, symbiotic enzymes, and organic acid and phytogenic compounds. So going to amino acids, this is kind of a one paper, really the first time in I think the word functional used a long time ago in around 1940s, but this is kind of one of the first paper, I would say, talking about functional amino acids in aquafeed. Okay, and it was a very interesting paper. I would suggest everyone to look at this paper, and you'll have much better idea about the specific amino acids. So In terms of functional properties, if you think about the amino acids, this diagram can tell us a lot. So they are involved in stress response, animal behavior, reproduction, metamorphosis, pigmentation, ammonia removal, endocrine status, antioxidative defense, immunity, and survival. So amino acids are involved into a lot of physiological activities in animal. And as you can see, there are essential amino acids, there are non-essential amino acids, and there are conditional essential amino acids. Today, we also talk about sometimes non-essential amino acids are also become important in terms of nutrition and health of the animals. For example, we talk about glutamic acid, and when we talk about yeast products, they are high in glutamic acids. So these non-essential amino acids are also important for physiological response of the animals. In terms of conditionally essential amino acids, hydroxyproline, proline, we talk about of them as well. And then some animal proteins are important because they are high in hydroxyproline. Hydroxyproline also have some immune properties. There were some studies have shown the effect of hydroxyproline in terms of improving the immune response of the animals. Now coming to vitamins and minerals. So vitamins are organic substances and minerals are inorganic elements, right? Coming from earth. Vitamins are coming from plants or animals. This is an article published a few years ago in Fish Shellfish Immunology, looking at the proteomic identification of the immune-enhancing proteins in shrimp, simulated with vitamin C and Chinese herbs. This is the graph that shows the phenyloxidase level in shrimp after 12 days and 24 days after inducing stress. So in control, you see the lowest production of phenyloxidase and is increased with vitamin C, and the further increase with Chinese herbs. And then the mix with vitamin C and Chinese herbs has the highest level of phenyloxidase in venoming. So this kind of interesting results, as you can see, that combination of vitamin C and Chinese herbs. We can explain this one more later, of effect of vitamin C and the role of vitamin C. This is one slide I want to show about. This is called ubiquitin proteasome system. In every cell, there is I call it a factory. So when animals are under stress, right, there's a protein breakdown. The protein breakdown increases when animals are under stress. And there was I think in 2006, the researcher who discovered this ubiquitin proteasome system was awarded the Nobel Prize in biology. And as you can see from the bottom, there's a short peptide pigments coming in, and then they can repair the protein. So when animals are under stress, there's a more protein breakdown. And for this system, there's a requirement for vitamin C, okay, to prepare the proteins. But not only vitamin C, they need another amino acids for that. So, and that amino acid is methionine. So vitamin C together with methionine helps repair the broken broken protein, okay? So increase the protein synthesis within the cell. So this is a very key thing to understand, the role of vitamin C, but it needs as well methionine to repair their proteins inside the cells. Okay. There's another paper published in Aquaculture also a few years ago. There's about the minerals comparison of chelated zinc and zinc sulfate as zinc sources. Okay, and very interesting findings, right? This is about again, we looked at the phenyloxidase production on the left and the mortality level on the right. If we look at the left figure, there's the highest phenyloxidase production was in zinc methionine conjugate, and lowest mortality was with the zinc methionine conjugate. Again, is the zinc is playing a role or with the methionine, right? So if we go back to that ubiquitin proteasome pathway, where with vitamin C within methionine, I think methionine is playing a major role in terms of having this responses in animal compared to other conjugate, other zinc conjugate or zinc sulfate, right? Now third is membrane active peptides. There are a lot of companies now are coming in with antimicrobial peptides. And I see that in feed industry, some of the companies are using antimicrobial peptides, and they can play a critical role as well in terms of managing nutritional health of the animals. So membrane active peptides are cyclic peptides from marine organisms, okay? And they are defined as a group of neutral or synthetic peptides between 5 and 60 amino acids. And they interact with the lipid bilayer membrane and disrupt the membrane. And by disrupting the membrane, they can kill the potentially pathogenic microorganisms. Okay. So they are called antimicrobial peptides or cell-penetrating peptides. All right. The fourth one, we'll talk about macroalgae. We have learned a lot from Dr. Fusi's presentation. I will just touch, I have just a couple of slides on this, and I will just talk about the Fucoidan compounds. This is a polysaccharides, sulfur-containing Fucoidan compounds are sulfur-containing polysaccharides and found in most brown algae. And this is another one paper I want to talk about in sargassum species about white spot virus resistance and immune activity in Peneus monodon. They said the Chlorella vulgaris, when they used Chlorella vulgaris and Chlorosaccharophilia, as well as Nanochloropsis and Chlorella as well. What they said with carrageenans, the survival rate was not as affected when they're infected with the WSSV, right? At the different level of carrageen over time when they use this, the carrageenan, right? The different level of carrageenan. And now we'll talk about the probiotic, prebiotic, and symbiotic a little. So there's a lot of farmers at farm level or some feed millers as well using probiotic in their feed or applying on top of the feed for farm application. And there's a wide range of effect of using probiotics. It is about managing the bacterial population within the animal or within the environment, right? So what happens is it's the communication between the bacteria, right? So when a pathogen becomes virulent, right? When there is the population exceeds a certain limit, they communicate that they release chemicals. We get quorum sensing, right? We know quorum sensing, so a specific microorganism releases specific chemicals. There's two kinds of chemicals. One is they talk between overall among all the bacteria, all the bacteria in the environment, and they also talk between their own species group. So when they say by releasing specific chemicals, so when they sense that the specific their population of their specific group is much higher, they release toxins to kill themselves, and that's when it becomes pathogen, right? That toxin harms the animal, affects the animal, and at the end the animal dies. So probiotic can application of probiotic and then adding prebiotic to maintain that probiotic bacteria population in the system can help disrupt this communication or reduce the level of communication between the pathogenic bacteria so that they don't become virulent. So managing bacterial population in the system, it could be within the animal or within the environment, is critical, and probiotics play a major role in terms of managing bacterial population, right? And so prebiotic and symbiotic. Prebiotic can be defined as non-digestible food ingredient that promotes the growth of commensal bacteria or beneficial microorganisms in the intestines. And And combination of prebiotics and probiotics are known as symbiotic, right? And in terms of prebiotic, they're insoluble and soluble. We talked about, there's a lot of talk among the monoligosaccharides, MOS suppliers. There's also a lot of studies with fructooligosaccharides. Xylooligosaccharides are recently coming up. There are some studies coming out with xylooligosaccharides. And we can find beta-glucans, you can find in insoluble form and as well as in soluble form, depending on the structure. And when we say yeast cell wall is a beta-glucan rich product, and there could be, depending on the structure, that could be 50% insoluble and 50% soluble, all right? And each type of structure, they have different properties. Their efficacy can be different based on their structure as well. The 6 is enzymes. I just have 1 or 2 slides just to show that enzymes also within the animal play a critical role to ensure the positive immune response. This is one study I would suggest also everyone, if they can find this paper, it would be very interesting to read about the phenol oxidase system in shrimp. And just 1 slide to talk about that. If you could, if you look at that, to produce a phenol oxidase, the prophenol oxidase system in the cycle is a serine proteinase cascade in the middle. As you can see here, there's a BGBP is beta-glucan binding protein, and there's and polysaccharides, gram-negative bacteria. When animals sense but this fungi, they're infected by fungi or bacteria, they produce phenol oxidase that cascade initiated, but this cascade, serine proteinase cascade, is initiated with a metalloprotease. So again, in metalloprotease, zinc is one metal that play a role with the protease. So they activate this serine proteinase cascade. So metalloprotease is zinc with a protease, or another metal with a protease. So when we talk about the use of zinc, again, the mineral, going back to the mineral, right? So zinc is playing a role in this system in case of shrimp. So zinc is playing a role in this case, in this cycle, activating the serine proteinase cascade to produce phenol oxidase at the end mineralization. Okay. Going to the last section, which we will talk about a little bit organic acids and phytogenic compounds, and I have seen some questions about plant essential oils products, and so this is just a few slides, and this is where we'll talk about the essential oil here. So this is you can see different sources of essential oil has different minimum inhibitory concentration for E. coli. In this case, basil has the lowest level of minimum inhibitory concentration for E. coli, followed by rosemary, cinnamon, and oregon, right? But with organic acids, essential oil exerts some additive, there are some additive effects, okay? So when we try to explain the organic acids, there are free organic acids, for free organic acids, they disassociate very early in the intestine. Okay, when pH level exceeds their pKa value, say there's different amino acids at 2 pH, most of the organic acids are in undissociated form, right? So, but as pH levels increase and they come out of the stomach in the intestine, the pH level tend to be alkaline, close to alkaline and alkaline. They disassociate, right? So they lose their efficacy. So we need to put very high dose, which reduces the pH in the intestine as well. But animal try to keep a homeostasis in their system, right? So then animal release some calciums to negate this low pH to become alkaline, to change the environment to alkaline. So when we use free organic acid, it creates and at high dose, and when we reduce the pH in the intestine, it creates a negative feedback. for the animal. So we need to be cautious when trying to use high level of free organic acid, okay, or organic acid salt. So how does this combination work, right? Essential oils disrupt the cell's membrane, we know, and it licks the vital components of cells, and then increase the penetration of organic acids into the cell. By that way, it reduces the pH, right? Internal pH. And animals try to spend a lot of energy to neutralize that pH. And at the end, because they exhaust themselves, they die. This is the kind of way of these two compounds act synergistically in managing the bacterial population in the hindgut. Okay, they have to reach the hindgut to be effective on the pathogenic bacteria, because the most bacterial population we see, the pathogenic bacteria, are in the hindgut. Okay, this is kind of our own study I want to show here. With some essential oil, we looked at the one is Aromonas salmonicida, which is a pathogen for Atlantic salmon, and another one is Flabobacterium columnare. That was very we called it cold water disease in rainbow trout, and we looked at different essential oils. We screened different essential oils. I will not name here. Essential oil 2, we see some significant effect on both pathogens, as well as essential oil 9 on Flabobacterium. But when we combined amino acids with organic acids, with 3 organic acids, and we see there's a significant additive effect, synergistic effect of essential oil 2 on both bacteria, and essential oil 5 on Aromonas, 5 and 8 on Aromonas, and 9 in Flabobacterium. So as we can see, when we combine with essential oil and organic acid, the efficacy can be improved significantly to reduce the pathogenic bacterial population in the animal. All right. This is a nice picture of Streptococcus. And you see here around the bacterial cell, there is a capsule or cilia, and with this, with the help of this cilia, they attach themselves with the intestinal epithelium, and that's the way they can they can enter, attach, and then they can enter into the blood system of the animal. Okay. So the study we did with the organic acid essential oil combination, you will see in the next slide, that cilia was completely gone. So besides increasing permeability of the cells, bacterial cells, this combination also removes the cilia. So they are unable to attach to the intestinal cell wall. So their efficacy, their negative effect is much reduced, and they are not able to penetrate within the body of the animal. Okay. I am on time. This is like I think kind of final slide. So the study was on in tilapia. We know a lot about we heard a lot about tilapia lake virus, if you know. The study was done in Colombia. So we put like 3 pathogenic bacteria together in the system, and as well as a macerated liver of tilapia lake virus infected fish, fed them for 1 day, and looked at survival for 50 days. So as you can see, the control, the survival was only 49%. Organic acid survival was only 78.6%, but organic acid essential oil was 91%. We compared that with the standard product used in the market for immune response and stress resistance in animal, like cell wall for beta-glucan, and still the same and higher, a little bit of higher than the cell wall, the organic essential oil product. So this is kind of interesting things, like we know what is happening in the gut with the bacteria, and now it manifested in the performance of the animal when under stress. Okay. So the final section of the presentation is the cautionary tale, right, of using functional additives in aquaculture or in any animal feed. So we need to decide properly what to choose. When we choose a functional feed additive, we need to decide why we need them. What are the purpose of this product? Are we using for specific growth or a specific condition? Is it for for cold weather tolerance? Some companies are producing a specific feed for tilapia raised in cold temperature. Some companies are producing specific feed for salmon to be raised in warm weather, right? So we need to identify our target use and then choose the additives, specific additives accordingly. And sometimes we, when we don't know, we rely on the supplier to give us information. We may have 2 or 3 additives with a similar, maybe different mode of actions, but the similar outcome. So we need to choose again wisely whether we need all of them or just one of them will be enough. That's why I said avoid multiple additives of similar functions. And the last but not least is the efficiency of the product, right? So we need to ask for real data when we choose a product of that specific product in our field, right? In our feed. I think that is the last one. And with that, I will try to thank you to everyone. And again, thank you InfoFish for organizing this webinar. And thank you all the attendees and the panelists, okay, esteemed panelists. Thank you.
Thank you, Dr. Kabir, for the insightful presentation. And I hope all the aquafeed industry will get benefited from this. So we have some questions for Dr. Kabir. How functional feed plays a role in improving the fish health and stress resistance?
I think it was in the presentation, right?
Yeah.
So we have to. I think there are different mode of action. So different additives can play different roles, right? So it could be intestinal health at the beginning. So we have to. So when we use prebiotics, we can improve the intestinal health, right? As well as probiotics, we can manage the bacterial population. And when you talk about internal body's immune response, we can talk about, some peptides could play an important role to create an immune response within the body, as well as some yeast component. We know beta-glucan, there's a lot of talk about beta-glucan. And so we need to attack this issue with the different mode. It's promoting gut health, as well as managing bacterial population, at the same time creating innate immune response in the animal. Okay, so we need to work on all this depending on the environment and situation we are in.
Yeah, thank you. There's one more question for Dr. Kabir. Are purified fucodian and carrageenan suitable for disease prevention, or fucodian and carrageenan containing macroalgae suitable for disease preventing mechanisms?
Very good question. I would prefer a compound product, because sometimes we see that purified product, blah blah blah. It's like it's magic. It's not magic. Okay, there are other things that are missing when you purify a product that we don't know. Seriously, there's a lot of. There was a presentation 3 years ago, known unknowns and unknown knowns, right? So I will say there are a lot of unknowns in what we know. So I prefer could be a cheaper option as well when we go with a compound product, right? So it's my personal preference, go for a compound product, because still we don't know a lot of things of this whole realm of, we say functional, but it's with a lot of compounds in one product has a lot of could have a lot of functional properties that we don't know yet. So that's why we choose fish meal all the time blindly, right? Because now we know a lot, but 10 years ago, probably we did not know much about fish, what the small micronutrients affecting animal health, micronutrient present in fish meal affecting animal health. But today we know a lot, probably some of these micronutrients. Does that answer questions, right? Sorry.
Thank you. Thank you. Now, there's one question for Miss Runa. What is the significant difference between fish meal and oil in comparison to krill meal oil with respect to its price competency and inclusion ratio?
Yes, so I actually already answered that question online. So what we are saying, there is actually a cost reduction adding krill meal into the shrimp formulation. Krill meal has expensive nutrients such as cholesterol and others, and therefore the feed producer reduces the feed cost, refreshing fish meal by krill meal.
Thank you. I think most of the questions have been answered by the respected panelists in the question and answer window. So thanks for that. There's one more question. Yeah, it's for Dr. Fusi. One second.
Yes, Andy.
Yeah. 1 second. Okay, till such time I'll finish this question readily available for Dr. Kabir. So, which is asking how and what way really organic acid and essential oil reduce the burden of TILV and enhanced immune system of tilapia?
Good. I was just typing that answer. Sorry. Yep. So when there was 3 pathogenic bacteria in that solution, as well as the macerated liver of tilapia leg virus, right? So what I see is that we had hence. So when we kill the pathogenic bacteria, they release also their cellular materials, right, within the gut. And as we know, there's a bacterial peptides and stuffs. Also bactericins sometimes within the bacteria, they kill other bacteria, and they create an immune response in the animal. So what I see is, so as the mechanism we mentioned as well in the presentation, essential oil, they increase the permeability of the bacterial cell wall. Organic acid goes inside, reduce the pH, they have to spend a lot of energy, they kill the bacteria. But the effect we see is probably from the peptides coming out of these dead bacteria. Okay, so it's like it's all the way you manage the population, and they also affect the growth of the animal or the immune response of the animal. Hope it answers the question a little bit.
Thank you, Dr. Kabir. Okay, now coming back to Dr. Fusi's question, I don't know if he has already answered. Has Corbion done taste panel tests on replacing fish oil in fish feed? If yes, on what species and what are the results?
Yes, I have answered to that question, so I can repeat it here. Yeah, we done taste panel tests on salmon as well as with Barramundi, the sea bass. And the results is quite amazing. The fish are more tastier with the algal fat, the salmon or sea bass. And there's actually a video. You can go online to algopine.com to look at there's a California, in Los Angeles, there's a chef, and then he went down to Chile to look at the salmon that grow in the cages, and he also sampled the fish and bring it back to taste. And those are the salmon that are fed with the algae. Yeah, they're more tasty.
Okay. So I think with that we are done with all the questions. Sujit, anything is pending?
No, you please go ahead with the panelist here.
Yeah. So we would like to give maybe a minute to each panelist in case you want to make any closing remarks. And especially I would request Dr. Tacon to say a few words about the impact of this pandemic, impact of COVID on aquaculture with respect to American region as well as rest of the world in terms of maybe it's not related to nutrition so much, but generally, say the consumption patterns in USA for the prawns or for the other seafood, which is the burning question in the minds of most of the aqua farmers now. When the demand will pick up. Maybe even Kabir can contribute, I don't know. Both are from the Western world, and of course, Ms. Runa also.
Dr. Albert already muted. Can you please?
Oh, I think we are
Albert will talk about the COVID.
Yeah.
I'm stuck in Canada, so due to COVID, that's what I can say. Last 6 months.
I think you have to. Yeah, unmuted
Okay,
now.
can you-
Yes.
can you
Now
hear me
we
now?
can hear you. Yes, sir.
No, I mean, I think the main effect of COVID on this part of the world is from the aquaculture perspective is that because demand is down, and because most of Asian producers or Latin American producers pay in dollars, at the end of the day, it's all about the exchange rate with the US dollar. And so the trend has been is that, ingredient prices have been increasing rather than decreasing. And because of demand and because of more production, the price of our aquaculture products has been decreasing rather than increasing. And so it behaves, it puts the focus on the farmer to always strive to reduce production costs per kilo of production, like I was saying before. And hence the interest of many feed companies, including yours, on functional feeds, because we know that the farmer's main concern, apart from price of the product, is survival, is health of their shrimp or their fish. So anything that can improve the health and survival of their animals, the better for them. But I think this is going to last quite a long time. Hopefully the vaccines will come. In Hawaii, where I am at the moment, we've just had the last month we had another lockdown because the cases were increasing, mainly because the young people believe that they are immune, and so they don't socially distance like maybe they should. And so we've had this spike in cases. Tomorrow, things start opening up. Restaurants will now be able to offer meals. People will be able to go to restaurants again. But the aquaculture sector, certainly in the countries that I work, Indonesia, Brazil, Guatemala, the industry hasn't been affected too much. In that, production is still quite good. The farmers are still quite active. The problem is the long-term trend on prices, and the fact that ingredient prices don't go down, they go up. And so it means that every year we must produce more from less. Less feed, less water, less energy. We have to be more and more efficient. So really, that was my only comment.
Okay, thank you. You would like to say anything, Ms. Runa?
Well, this is a bit of a big and dangerous question, of course, to dive into without preparation. I guess one thing that we saw was a positive thing when COVID hit was that because we are defined or classified as like critical to society, food, we were actually able to trade across borders and even transport people across borders in very controlled manners, even with the lockdown. So this, I guess, is an important thing. Another, if just on top of, I think the whole COVID situation has really drawn attention to the interaction with nature and wildlife and how we must be a bit more cautious about this. And I think one can argue the case that a controlled aquaculture, where you sort of have a very controlled interaction and food production in this way, could be strengthened.
Okay, thank you. One last question we'll take, and then maybe each panelist can take a minute in case they like to add something on their own. So this question is for Dr. Albert. Where to find all the new ingredients hitting the market? Are there any websites or open source data?
I think I answered that question.
Okay, fine.
But like you say, there is an international feed ingredients database that was developed by the University of Guelph in collaboration with USEC. But basically, you know, of course there are many new ingredients, and normally the suppliers of these ingredients go to you to grow out to the feed companies and try and obviously sell their products. But I think the important thing is that when people have a new product, that they come along with also supporting information to prove the effectiveness of their product in the field, not just, you know, indoor laboratory experiments, but experiments performed under farm conditions.
Okay, thank you. So I think we are done with this. So before closing now, I would like to invite Ms. Sherlyn Maria Antenosamy, Director Infofish, to say a few words. Yes.
Again, a big thank you to each and every one of you esteemed panelists for your time. Dr. Tacon, I know we are all at different ends. Dr. Kabir, very much early, Dr. Tacon, very much late. We are somewhere in between. We are just at exactly different time zones of the world. So anyway, really appreciate your time, and I think it was a very valuable webinar with a lot of information that I think participants really valued. So thank you again. Also, Dr. Husi, for representing Corbion, and also for exclusively sponsoring this webinar. Very fruitful. Mr. Sandeep, thank you very much for effectively steering the webinar and handling the questions and so on.
My pleasure.
Special thanks to each one of you for helping to answer the questions on this Q&A. I wish you all have a pleasant day, a good night, and just reminding all those participants for also to join us for our upcoming webinars, which have already been posted on the chat. We have our tuna prelude next month, and on the fisheries, tuna fisheries in the Pacific in November coming up as well. The video for this webinar today is available on our YouTube channel, so you can subscribe to our channel and then also have access to the previous webinar recordings. So again, once again, thank you very much. Have a pleasant day. Thank you to Corbion again for sponsoring us, and see you all at our next webinar.
Thank you very much.
Thank you, Sherlyn. You're welcome.
Thank you.
Bye-bye, everyone.
Thanks
Thank
to all
you.
the
Bye-bye.
panelists
Thank you, Fusi.
and
Okay,
all the
bye-bye.
participants.
Bye-bye.
Bye-bye.
Sawadee krap.
Sawadee
Yeah.
krap.
Terima kasih.
Terima kasih. Sama-sama.
Okay, bye.
Sama-sama.
Terima kasih banyak.
Bye-bye.
Yeah.
Hey, thank
Bye-bye.
you. Thank you, Fusi,
Bye-bye.
for the event. Okay?
Bye-bye.
Thank you.
Most
Thank you.
welcome.
Bye.
Pleasure.
Okay. Bye.
Bye-bye.